Everyone, welcome back to the Code2Conquer series, your step-by-step guide to mastering DSA for placements. This campaign is brought to you by Google Developer Groups at VIT-AP. Now, we've completed 18 days. The problem 1 and 2 of 18, and now let's move to the third problem. This is a continuation of the previous two problems. So, what does the problem statement say? We'll be given with the head of the linked list, and we should be returning the length of the loop. So if there is no loop in the linked list, we should be returning 0 because the length of the loop is 0 over there. So this is what this is the description, and this exactly explains what I just said. So coming to the input, we'll be given with head as our input. So we should be displaying the length of the loop. Now let's look at some test cases. For this linked list, we'll be having 3 and 4 in a loop, right? So the length of the loop is 2, so we should be returning 2. Coming to this, there is no loop in this linked list, so just return 0 because there is no loop. And coming to this, this has a loop, and 1 2 3 4 5, so there are 5 elements in the loop, so just return 5. Now this is all about the question. Now let's come to the coding part. See, you will be given with the head as the input in the function, and we have to return the number of nodes in the loop. So we'll be having a brute force and the optimal approach. First, let's discuss about the brute force approach. So coming to the brute force, see, initially we'll be given with this, and now we have to return this length of this loop. So what can we do? Think of an approach. So what if we know the initial positions of every node? 1, assume 0 indexing. Assume so 1 will be at the 0th index, 2 will be at the first, 3 at the second, 4 at the third, 5th at the fourth. Now we'll be going to 2 again, right? And initially 2 was at 1, first position, assuming 0 indexing, and fifth was at, and fifth is at fourth position, 0 1 2 3 4. Yeah, fifth is at fourth position. So it would be better if we remember our initial positions of our linked list, so that if we come to a node again, we can subtract it. See, now 2 is at fifth, right? If fifth is at fourth, then 2 will be again at fifth. So initially it was at first position. So 5 minus 1 gives us 4, which is the length of the linked list. So if you can remember the positions of the node, of every node, then if you visit a node again, it will be the first node, right? If you visit something first time, it's the first node in the loop, and you can subtract its current position with the initial position in the map, and you will have our answer. Now let me explain how and why. See, initially we should be creating a map data structure, hash map for now. So we'll be creating map which will be storing the node and its position, right? So pointer called temp towards the head, so that we can traverse to the entire linked list, and use this variable, int variable, for counting or having the values of the node, the positions of the node, for the positions of the node. So while temp does not equals null, so while we do not reach the null, if our visited nodes is our map, right? So if our map already contains this node, then do these 2 steps. Initially our map will not be containing any nodes, so we should be doing these 3 steps till we reach to once again. So visited nodes dot put temp comma count. So we'll be putting our node and our count, which is initially 0, and then we'll be moving our temp to the next node, and we'll be incrementing our count. So let me do a dry run so that you will understand this. So initially our count is 0 and our temp is at head. See, our temp is at head and our count equals 0. Next, 1 is not in the hash map, So put it in the hash map. So hash map will be like this. Node 1 is at position 0. Then go to 2, right? After going to 2, our count will be 1, temp is over here. So put 2 comma 1, because we are putting the elements in the map before incrementing the count, right? So at 2, our count will be 1 and 2 is our node. Similarly, like this, we'll be moving our temp. Count will go to 2. So 3 comma 2. Similarly 4 comma 3, 5 comma 4, 6 comma 5, 7 comma 6, 8 comma 7, 9 comma 8. Now comes 3 once again. So we'll be having 3 comma 9. We should be having 3 comma 9, but our count over here is 9 and our temp is over here again. But this if condition will run because our map already contains this node. This if condition will run. So coming to this, we'll be having a variable called loop length for count minus visited node got get temp. So count over here is 9 minus map dot get temp. What does map dot get temp give? 2, because map dot map dot get 3 will give us 2, right? So 9 minus 2, which will be 7. This will be gone to loop length and will be returning loop length. So we'll be returning 7. Now let's look if our loop is of length 7 or not. 1, 2, 3, 4, 5, 6, 7. See, this is exactly what you have to be doing. So I hope you got this method because you saw dry run, right? So I guess you are clear with it. So coming to the time complexity and space complexity. Time complexity would be around big of n because we are traversing through the entire linked list till we reach a node again. So we are traversing through every node possible. So the time complexity will be big of n. Now coming to the space complexity, it will be big of n as well for storing these values in the map. So yes, I hope you got complexities as well. Now let's come to the second approach or the optimal approach. So we've been discussing this method since the first problem. So we will be using the same strategy. Create a slow pointer towards head, create a fast pointer towards head, both pointing towards head, and also use a count variable. Now slow will move one step forward and fast will be moving two steps forward till fast reaches null or it reaches the last node, because if it reaches the last node it cannot move two steps further, it can only move one step. So if slow and fast meet at a point, which means that if there is a loop in the linked list, we can find the loop length, right? If there is a loop in this linked list, we can find. If there is no loop in this linked list, this if condition will not run and will be returning 0, right? So if there is a loop in this linked list, I created a do while over here. So I hope you won't get confused. If you cannot understand this or you're getting confused, let's do one thing. Count will be initially 1 while fast does not equal slow fast dot next fast equals fast dot next increment the count. So after this while executes, just return count. So first let me explain this do while, then we'll be coming to this if you cannot understand the do while. Yes, so let's first come here. So if slow and fast meet, what does this mean? They're already in the loop, so they cannot exit the loop right now. If they're in a loop, then they'll keep continuously moving in the loop itself. So move your fast one step further, increment the count. Move your fast another step forward, increment the count. So what are you doing? You're just moving your fast through the loop, and you are incrementing count for every step till fast reaches slow again. So as soon as fast reaches slow, you have incremented count the number of times, and you'll be returning it. Then the number of nodes in the loop, and you'll be returning it. Let us do a dry run so that you can understand. I have come with a similar, the same example. So initially slow will be over here, fast will be over here, and after continuous fast moving 2 times and slow moving 1 time, they both will meet over 8, right? Slow and fast both will meet over 8. So there is a loop in this linked list, and they are in the loop, they cannot exit the loop. Now what did I tell? Just have a counter variable, count equals 0 initially, and fast will be over here itself. Now move your fast one step further, increment the count. Fast will be over here, count will go to 1. Move your fast another step, count will be made 2. Move fast, increment count. 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 So they meet again. So if they meet again, just immediately stop and return count. So we'll be returning 7, which is the length of our loop. See, 1, 2, 3, 4, 5, 6, 7. This is our length of the loop, and we'll be returning 7. So as soon as both fast and slow meet, just increment fast by one step and increment the count. Move fast to one step and increment the count. So as soon as they meet again, just stop the execution and return count. So I hope you got this method as well. Now instead of this do while loop, we can even run this. But initially you should be making sure that you initialize count with 1. So yeah, it's nothing, it's the same thing, but a better thing, because if you cannot understand do while, you can do this. So I hope you got this as well, because we did a dry run. And coming to the time complexity, in the worst case scenario, it will be a big O of n as well. Now coming to the space complexity, it will be big O of 1, because we are not using any extra space. We are only using 2 pointers, slow and fast. And I hope you got this question right, finding the length of the loop in the linked list. Now this brings us to the end of day 18, and I hope you understood the 3 problems which we solved today. And yeah, thank you.